Application problems. Please keep this in mind. When solving application problems that lead to quadratic equations, there might be a solution that does not satisfy the physical constraints of the problem. For example, if x represents the width of a garden and the model equation is quadratic with two distinct solutions, one of the solutions might not make sense. If one solution is positive and the second is negative, then the negative solution must be discarded because the width of the garden must be positive in value. In a case like this, the discarded value is called an extraneous solution. Let's consider a category called number problems that lead to quadratic equations. Turning words into algebraic expressions is the starting point for this category of problems. The natural numbers, 1, 2, 3, 4, etc., are modeled by n and n plus 1. The whole numbers, which include all of the natural numbers and 0, are modeled by n, n plus 1, and n plus 2, or you could even have n minus 1, n, and n plus 1. The integers, which include all of the negative numbers as well, are also modeled by n, n plus 1, n plus 2, and so on. Here's some practice changing words into mathematical expressions. The sum of three consecutive integers would be n plus 1 plus n plus 2, which when you simplify would be 3n plus 3. The product of consecutive even integers would be n times n plus 2. The reason why we add 2 instead of 1 is because we want them to only be even integers, so every other one. And when you simplify that, you get n squared plus 2n. This one is a little more confusing. Twice the product of the first two of three consecutive integers is added to the sum of the second and third. So we have 2 times the product of the first two numbers, n and n plus 1, plus the sum of the second and third number. The second number would be n plus 1. The third number would be n plus 2. So when you simplify this, you get 2n squared plus 4n plus 3. The product of consecutive negative odd integers is 143. What are the numbers? Alright, so we're going to use n and n plus 2 to represent our two numbers. Because it says odd integers, we just need every other number, so we won't include n plus 1 here. So we have n times n plus 2 equals 143. So that's n squared plus 2n equals 143. We'll move the 143 over, so we have n squared plus 2n minus 143 equals 0. Now we'll factor this. There's going to be one positive and one negative number, and they're going to have a difference of 2. So 143 is 13 times 11. Because this one's positive, that means 13 is positive and the 11 is negative, giving us answers of negative 13 and positive 11 here. But what are the numbers? Well, they're going to be negative 13 and negative 11.